Okay, we just finished learning how to operate a geometry. Okay, now let's go back to the beginning and implement a little generated art visual effect that we just saw at the very beginning. Let's create a box first. We follow the box with a transform to resize it, adding the rendering system after transform. Geometry, camera, and light. In this project, we don't really need light. You can delete it, and then render, add a null at the end. Click on this little blue dot and we can show it. The effect can be achieved with only two SOP components. So the first one is noise. The noise is the same as all the noise we've seen before. This noise SOP is the same and it can input our model. It can make the value of the XY axis of each point of it change randomly. We see that this is a bit strange in the picture now. It is that every points can't be aligned. Why is that? Because we have so few subdivision surfaces, we have so few points. Let's go back to the first box and click W, and we also see that there are only 8 points in total. So what do we do at this time? Let's go put some points on it, shall we? We click on Use Divisions and we add it directly to 3 by 3 by 3. Now it's a little bit smoother than just now, and we can add it again. For example, we add it to 20 by 20 by 20. We can see that it has become much smoother now. We add a twist behind noise. Through twist, we can directly distort a model that we input. For example, our current target is a distortion of the x-axis, and we directly increase its distortion force. We can see that the value here on the x-axis has begun to become distorted, and we can also change it. Let's try it on the y-axis. It is a vertical distortion. The z-axis is a twist towards us, and we choose the z-axis. For example, we can look at the effect if we turn it off. The whole picture doesn't move anymore. It's just a simple twist effect, so you can see it more clearly. Okay, we turn on this noise, and we see why this noise is moving. Because it adds a growing number like abstime.seconds to us by default. Okay, now let's go to create a material for it. We found line MAT in the MAT. We can see that the picture itself is actually a wireframe style.so. We don't use line MAT to generate a wireframe to render it at this time. We drag it to the geometry. Click on the first material. It will be given a material that we just gave it. What can we change here in line MAT? One is its distance, which is the distance of our material. We can see it here, according to the distance. We can adjust the width of its line below. For example, if it is close, it may look very thick, and if it is far away, it will look very thin. An effect of big near and small far. We can make it a little thinner. If we adjust this parameter, we can probably see the whole effect. Far away, its color will become slightly more transparent and thinner, and closer, it will be thicker. We can add a background here so that we can see it more clearly. Let's insert an RGB key here. We've talked about a few ways to add this solid color background before. You can give it a black background directly. Okay, here in line MAT, we can click on line, and here we can adjust its color. You can adjust the color close to us. For example, I adjust it to red. As you can see, it's obvious that the place near us is red, and the place far away from us is gray. I can change it to white, and the place far away is white. Okay, this place can be adjusted according to your own preferences. Like our initial effect, we're not using line MAT at here. We can turn line MAT off. We click on point and we generate points for it. Click point, and what we generate here is not every line but every endpoint. The whole model part is like this, and we're going to do some visual processing now. We drag it back, drag it, and create some space for us. We click the middle button after render to create a feedback, or the feedback we talked about earlier, add a level after feedback. Add a composite to the whole main line. Change its operation to add and connect it. Finally, drag composite to our feedback. I won't drag it now. Let's think about what kind of effect the whole connection will produce. Yeah, when I'm connected, the operation of all components on the line after feedback will be an infinite loop, and I add a level after it. I made it less transparent. Then it will have a smear effect because the transparency of each frame is 20% lower than that of the previous frame. Let's drag first. Now we can probably see an effect just now. If I don't think it's enough here, let's go back to the original box, and we can continue to adjust its staging partition. You can make it have more points, no problem. Okay, finally, let's give it a color. Now it's white, which is not very beautiful. We use a way of coloring. In the palette it provides in the official plugin library. Inside one of the filters in the image filters image, drag down to find the Raba Delay plugin, and we drag it out. Connect the first input and then change its output to it. We have also introduced the Raba Delay plugin before, which can delay the R, G, and B channels in this screen. In this case, the R channel is delayed by 15 units. G channel 10, then B channel 5. In this way, we can see that it has such a rainbow effect of RGB. Here we can also go to adjust a little more exaggerated. Are completely based on their own design to complete. Okay, here we can also adjust some parameters of nice noise, such as its period. In fact, it is similar to the noise top we talked about before. The effect of reducing and increasing its period is very obvious. And amplitude, we also talked about it before when we increase the amplitude. The maximum and minimum values of its entire noise will become very ridiculous, and we will reduce it. Shrink to a little bit of the effect can be good. You can also keep trying other parameters. Okay, we have a guide lesson of SOP, a simple introduction of SOP operators. This is the end of a small attempt in the case. I hope you can also achieve more interesting other effects based on the case we see now.